Welcome, everyone. My name is Tanwa Arpornthip. I am the technical advisor at SCB 10X. And with me, I have Mustafa Al-Bassam, the CEO and co-founder of Celestia. Welcome, Mustafa.
Hello. Hello, everyone. Good to be here.
So in today's earlier sessions, like a lot of people were talking about a lot of things that I'm sure would come up again in this session. For example, data availability, consensus, security of the change, unbundling things. And I'm sure that's going to be one of the key topics that we talk about today as well. But before we go into the details, can you give us a brief overview of Celestia? And maybe talk a little bit about how it is different from other blockchain architectures.
Yeah, sure. So what is Celestia? Celestia is what we describe as a pluggable consensus and data availability layer. What that means is that Celestia is basically a very minimal layer one blockchain, in the sense that we've built a layer one where we've kind of like taken back the core components for layer one to just what a layer one needs to do. So that, for example, like Celestia does not have a smart contract environment or smart contract platform. You can't deploy smart contracts on Celestia. Instead, you can only use Celestia to post data and get consensus on data. And this provides a very basic but powerful primitive for developers to kind of create their own chains as in the form of roll-up chains on top of Celestia. And this is what we describe as a modular architecture. We provide the consensus and data availability, and that allows developers to define their own custom execution environments. And that's why it's modular, because you can kind of like swap, you have a modular ecosystem where you can replace data availability layers, and you can now create your own execution environment without having to go through the overhead of having to create your own layer one from scratch.
Mm-hmm. And just for the sake of the audience, for all the other L1s out there, not all of them, like the majority of them, you basically have four modules, right? You have the data availability, you have the consensus, you have the execution layer, which is also called the smart contract layer, and you have the settlement layer. So what you were saying was that Celestia would focus on just being the consensus and the data availability layer for people to build blockchain on top of Celestia.
Yeah, exactly.
Yeah.
So like in traditional blockchain architectures like Bitcoin or Ethereum, they kind of like follow this like world computer model where the chain is responsible for all the parts that blockchain is supposed to do, consensus, data availability, and execution. And for example, under the original Ethereum model, it was described as a world computer where every application smart contract runs on the same blockchain. But obviously, we know that doesn't really scale very well. And so that's why, for example, like Ethereum has now a roll-up centric roadmap where you're not expected to, in the future, you're not expected to use Ethereum directly for execution. You're expected to use a roll-up that uses Ethereum for consensus, but the execution happens off chain on a roll-up chain. And so Celestia is kind of like basically we're building from scratch. If we were to design a blockchain that is designed from scratch to only focus on consensus and data availability and scale that well, what would that look like? And that's basically what we're doing at Celestia.
Mm-hmm. Let's take us back a little bit though. I was told that Celestia used to be called Lazy Ledger, and that that was a paper you published back in 2019. So it has been a long journey for you coming here, 4 years up until now and more. What's the difference? Like, what was Lazy Ledger, and what is the development between Lazy Ledger until it becomes Celestia today?
Yeah, so Lazy Ledger was the original paper that I published in 2019 that kind of like described the idea of Celestia. And yes, Celestia used to be called Lazy Ledger, and like at the start, it was just like an academic project. It was never at the start there was no intention to have commercialize it, which is why we just use a funny name. But then it started to make sense to commercialize it when rollup started becoming more recognized as a scaling solution. But the name Lazy Ledger, the reason why it was called Lazy Ledger is because it's like a very lazy blockchain. It doesn't do execution. like it just publishes data, and the execution is meant to be done off chain or by rollup chains. And so that's why it's called lazy, because like it's a lazy ledger in the sense like it does not do any computation on data. The computation is done off chain or by the end users.
So that was the original concept, and basically you just took that and made it into Celestia today. What motivated you to create this modular blockchain concept to begin with? What are some of the key benefits compared to traditional monolithic? In addition to what you have proposed, which is that people can choose their own execution layer. Like, what motivated you to go this route?
Yeah, so I think like when any technology matures, it naturally kind of modularizes. So we've kind of seen this evolution of the web as well. So it's like when the web was first created, if you wanted to kind of create your own website or host your own website, back in the old days in the 90s, you would typically have to have your own physical hardware or physical server. Like you could run your website on your own computer and keep it online all the time, or you could like run your website on a university computer. And like obviously that's a lot of overhead just to host a website or any kind of like internet service. So then like in the early 2000s, you had this idea of shared web hosting providers that started popping up. Like GeoCities, for example, was an early example, but then you had like stuff like DreamHost, Bluehost. You could just sign up and you could upload your code, and your code would run on the same server as other websites. But the main limitation of that is that you were very limited to how you could develop your website, because you were limited to whatever programming languages or software that shared hosting provider had. So like back in the day, you just every website had to be created in like PHP and MySQL. Like there wasn't like, Ruby, Python, like you can't like run a Python script or use Rust or other kind of like technologies. But then kind of like in the mid to late 2000s, this idea of virtualization started becoming popular, and this idea of virtual machines. And then with the virtual machines, that allows you to have the best of both worlds, in the sense that it made it possible within seconds for you to have your own virtual server. We have full control over it, and you can deploy whatever you like over it, without the overhead of needing to maintain physical hardware. Blockchains are following a very similar arc. So like in the late 2008, we had Bitcoin, and Bitcoin was like a blockchain for one application. And then it's like to create a new application, you had to create your own chain. So there was other chains like Namecoin, Litecoin, Dogecoin. There was like one chain for each application. Every application needed its own chain. And then Ethereum came about, and Ethereum made like a shared blockchain, just like you had shared hosting providers, that anyone could upload their own code to it in using the Ethereum virtual machine. And you share computation with every other application that's running on that chain. But then the natural evolution is now we have rollups, and rollups are like virtual blockchains. You can now create your own chain and have your own execution environment, and not have to share the same computational resources as other smart contracts, but without the overhead of needing to deploy your own layer one consensus layer. And that's what made possible thanks to modularity. The fact that we can have modular consensus layers and modular execution environments means that you can now kind of like easily deploy your own chain with its own execution environment without having to go through the overhead of maintaining your own layer one consensus chain and having to bootstrap an entire validator set and proof of stake protocol and so on and so forth.
Mm-hmm. So modularity gives people more flexibility in development, make it cheaper for them to start the project the way they want to, right? Which I see this theme woven throughout all the Celestia material. I see it on your website. I see it in your tweet. In fact, I'm going to quote one of your tweets right now. You were saying, modularity is about being collaborative and allowing different layers in the stack to work with each other in a multi-chain ecosystem, rather than having an endless loop of new L1s with their own maximalists. And you were saying modularism, not maximalism. Like, can you expand on that philosophy that has been driving Celestia up until today? Like, what does that mean to you, and what does that mean to the crypto economy in general?
Yeah, sure. So I think like over the past 10 years, we've been kind of stuck in this loop, which of like new layer ones. Like every single cycle, you have new layer ones that claim to solve the problems of previous layer ones, and each of these layer ones have their own kind of like community and tribes, and it's very tribal. It's like my layer one is better than your layer one. Like in 2016, we had like EOS, and other like IOTA and other layer ones, and those kind of like fell out of popularity, and then we had new layer ones in the last cycle, like Solana Avalanche, and now in this cycle we have like Sui and Mistin, Sui and the other one
Aptos.
Aptos, and it's now like it's not really sustainable that we have like every cycle we have this like constant cycle loop of new layer ones to fix the problems of previous layer ones, and then having to like bootstrap entire new ecosystems of these layer ones with their own tribes that compete against other like layer ones. So it's like it's not a zero sum game, and it's like if we're stuck in this cycle, it's like we're kind of like stuck in like a zero sum thinking, where it's like you just forget about all the old technologies that's been created, just create a new ecosystem with a new layer one. Like for example, like Sui and Aptos are basically creating brand new ecosystems with the same applications as Solana and Ethereum, like NFTs, the same NFTs, the same namespace service apps, and so on and so forth. Just copying and pasting entire ecosystems into new layer ones just to make incremental improvements, and that's not really sustainable. Instead of like creating entire new ecosystems just to make new incremental technological improvements, instead we should adopt a modular framework where, like for example, now if you wanted to create a new improved execution environment, for example, that has parallel processing, for example, like Sui has a very good new execution environment that is potentially faster than other ones, but it's an incremental improvement. But instead of like creating a new layer one, you can just create your own. You can deploy a new rollup chain within seconds with that new execution environment. And that's a more iterative process. That's a bit more iterative and positive some way of like creating a kind of like blockchain ecosystem where different components can work together instead of having to create entire new ecosystems. And so that's why I say modularism, not maximalism. Instead of like being maximalists or tribal for your favorite layer one or your favorite coin, instead we should have a modular ecosystem where it doesn't like developers should have the freedom and flexibility to choose what technology they want to use without being locked into a specific ecosystem or specific tribe.
Mm-hmm. Gotcha. This reminds me of XKCD comics. I don't know if you read or not. Like the first panel would say, you probably know which one I'm talking about. Like, oh, there are 14 programming languages. And then one guy was like, oh, we should fix this, and all that. And they come out with their own new language. And then at the end panel, it was saying, now we have 15 problematic languages. So I feel the same way with you toward layer ones. Like we just keep seeing more and more layer ones trying to solve more and more problems. And at the end of the day, you start to have tribes trying just basically, fling mutts at one another. So that has been an interesting development to me as well. I want to dive deeper into the technical aspects of Celestia a little bit. Earlier, you were mentioning that one of the key benefits of Celestia is the scalability of the technology. So can you explain how Celestia would be able to achieve the scalability that might not be available to a monolithic environment or a roll-up environment?
Yeah, sure. So Celestia only tries to focus on doing one thing and doing one thing well, and that's consensus and data availability. And when it comes from a resource pricing perspective, if in a modular stack, if chains kind of specialize for different resources, you can get efficiency guarantees. So, like for example, like if a chain is trying to do multiple resources or trying to offer multiple resources, like they're trying to offer data availability and execution, and trying to resource price them in the same way, it's not as efficient as if you have specialized nodes that only need data availability, that only focus on bandwidth. They have very high bandwidth requirements, but low computational requirements, and have different nodes that are only responsible for execution, and then focus just do that very well. rather than like one node trying to do everything and not trying to do everything, but not specializing well in one particular thing.
So in economics, it would be division of labor and specialization, right? You have people specializing into doing different things. Like I wouldn't be any good growing apples, for example. Like you wouldn't get any apples to eat, right? That's why I'm doing this here. So I think that's what you touched upon just now, that Celestia only focus on doing two things and two things really well: the consensus and the data availability.
Exactly. And another aspect of it is that the data, we kind of use this primitive called data availability sampling, which allows us to make it possible that you can increase the block size while still making it possible. Well, we can increase the block size by increasing the number of nodes in the network. Whereas like traditionally it hasn't been possible with previous chains. And the reason for that is because each light node downloads a very small chunk of the data of each chain to verify it's correct, to verify it's available. So the more light nodes you have, the bigger the block sizes you can have, and the more data that you can have consensus on and make available.
When I read about this, I thought it was really fascinating because for almost all blockchain out there, you rely on people having majority honesty, right? Otherwise, you have 51% attack. But for data availability layer, you only need minority honesty because people can go and check whether data is available or not. And if it's not available, then that data is therefore its fault. Can you expand on that a little bit and the power that come with only having to rely on minority honesty as compared to the majority honesty?
Yeah, so this is it's a very common misconception that people have about blockchains, where they think like, okay, like blockchains like Bitcoin and Ethereum, they have like miners or validators, and they assume that the kind of like security model of a blockchain is such that you have to you have to trust that there's that 51% of the majority of the validators are being honest, otherwise they can steal your money or like they can change rules of the chain. But actually that's not true, because with Bitcoin and Ethereum, for example, the whole point is that end users and organizations and businesses, they can run what's called a fully validating node, or a full node for short. And a full node, they download the entire chain and they check that all the transactions are correct. And even if there's a dishonest majority of validators that try to push in an invalid transaction, they will actually reject that block. They will reject that block and treat it as invalid. So the validators are not trusted to abide by the rules. And this is fundamentally the whole point of blockchains, and what differentiates Web3 from Web2. And what differentiates blockchains from databases, or like Web2 databases, is the fact that you don't have to trust any middlemen, including the block producers. Instead, you have a protocol rules, and no one can violate those protocol rules because the chain is verifiable. Everyone can verify that those rules are being followed. But the problem is that if you have too many transactions on chain, the resource requirements for end users to run a full node increase. And that's why we use technologies like data availability sampling and fault proofs and ZK proofs to make it possible to increase the block size while still making it possible for end users to verify that the chain is correct. The problem is that if you take a Solana approach, for example, and you just have extremely big blocks, then the only people that can verify the chain are like people with expensive machines or servers. And if end users can't verify the chain, then you're basically handing power to only people that can afford to verify the chain. You're handing the ability to change the rules of the chain in a way that the community doesn't agree with.
Mm-hmm. Wait. Another aspect that really interests me when it comes to Celestia is the interoperability of Celestia with other blockchain. Because of course, having a multi-chain ecosystem has been one of the talking points in the past few years. How does Celestia support interoperability with other blockchains, and like where exactly is the liquidity? Where are the tokens, and what are some of the challenges involved in trying to achieve this interoperability with other blockchains?
Yeah, I mean, so Celestia, when people think about interoperability, kind of the correct way to think about Celestia, like Celestia is not a kind of like a liquidity ecosystem in itself. Celestia is not in the same way like Solana or Ethereum are. Instead, like Celestia is meant to be like a very simple primitive for people to create clusters of chains that are that can be interconnected with each other, that may be kind of centers of liquidity. But Celestia itself does not aim to be like kind of like a center of liquidity in itself. It's more like a basic primitive to launch kind of like centers of liquidity. So, like for example, like you can launch roll-ups on Celestia that have bridges with each other. Kind of like how Ethereum is itself, Ethereum and all the roll-ups on it are considered to be like an ecosystem or like a liquidity ecosystem, or what I call a shared security zone. You can deploy your own shared security zones on top of Celestia. So it's kind of like Celestia is like even more basic and primitive than Ethereum. But that being said, like Celestia itself can be bridged. Like we plan to support IBC, enable IBC, which is like inter-blockchain communication protocol, because we're a Cosmos chain. So you will be able to bridge Celestia to other chains in the Cosmos ecosystem, and also to rollups on Celestia via bridging providers.
Mm-hmm. So besides unbundling, sorry, go ahead.
Yeah, but just like ultimately, because Celestia does not define the execution environment, it's up to the rollups that define the execution environment to choose how they want to bridge with each other.
Mm-hmm. So besides unbundling the all the layers of a blockchain, like what sort of new applications are made possible by doing this? Because it seems to me that you are changing the primitives of a blockchain, but from users' perspective, they're still going to be using the same kind of applications, or are there any kind of innovative applications that can come about by using Celestia to build up a blockchain instead of using existing L1s?
Yeah, so I mean, I think fundamentally the question is like, it's not like Celestia is a general platform. So in theory, like as long as you have a ledger, you can build any application on top of it. So it's not so much that Celestia enables completely brand new applications, but it's more that Celestia makes it possible or practical to make it possible to deploy applications that might not have been previously practical before to deploy, because they might not have been cost efficient to deploy because previous blockchains didn't have enough data throughput or scale. Or for example, like it makes it possible to deploy new execution environments with benefits that otherwise developers might not have done because it would have been too much overhead. Like an interesting example for that is like people are building EVM gaming chains. There's like this companies doing this, like like Argus, for example. There's people building gaming chains, and also like other projects like Caldera. They're building gaming chains, but on the EVM. But what they're trying to do is not possible easily in the EVM, at least in a scalable way, because the EVM just doesn't support that. And like you might want to build a game that has like is very fast, for example. Like if you want an EVM might not, the structure of the way EVM works doesn't support that. So like one thing that people have been doing is they've been modifying the EVM to add new opcodes to it to make certain things possible that haven't been possible before. And the only way you can do that is if you have the ability to define your own execution environment. You can't just like do that on Ethereum right now because you have to use the same EVM that Ethereum uses. But with modular blockchains, you can now like take the EVM, modify it to your needs, like add a new opcode that makes things way easier, and then deploy it as a rollup chain instead of having to deploy your own entire new chain from scratch.
Mm-hmm. Okay, gotcha. So Celestia in and of itself doesn't really interact with the application developers, but it allows application developers to have more flexibility in defining the execution environment that they need, the scalability level that they need, and the trade-offs that they need to have in order for their application to be reality. Right. So it basically gives more flexibility. I loved your earlier analogy or example about GeoCities, because that just gave my age away when I smiled because GeoCities brought back some memory. So yeah, I totally understand what you were talking about when you were saying flexibility allows people to be more creative in what they are trying to make happen, and that's great. So let's talk a little bit about the application side and the future forward statement of Celestia. How do you see Celestia evolving over time as new use cases and applications emerge being built on top of Celestia? And what role do you envisioning you and Celestia play in the broader blockchain ecosystem?
Yeah, so I think like ultimately Celestia is kind of like to some extent the extension of the Cosmos vision. And ultimately, like kind of like our vision is that we anticipate an ecosystem where there's potentially millions of blockchains, like because each application will have its own rollup chain, and deploying a new blockchain will be very easy. It will be as easy as deploying a new blog or deploying a new smart contract, and it will become the preferred way to deploy new decentralized applications because you get the best of both worlds. You get your own dedicated computational resources and execution environment with low overhead. So there's going to be and there's an emerging kind of ecosystem of roll-up to service providers where you can like literally upload your roll-up code, click what the ALA you want to publish it on, what execution environment you want to use, and the certain properties of your roll-up, and it will deploy it instantly. So that's kind of like from a technical perspective, that's where kind of like we see things going. And Celestia is here to kind of like try to make a very scalable data layer to enable that ecosystem and to enable it to flourish.
Mm-hmm. So from competitive landscape standpoint, and I think this is going to be our last question, many L1s also allow a lot of customizable deployment. You have Avalanche subnet, you have Cosmos app chain, Polkadot parachain. Why are those not enough, and why should developers consider Celestia?
So the problem with things like Avalanche subnets or like Polkadot chains is that they don't solve the problem that you need to. They're very high overhead because you have to, for a subnet, for example, or a traditional Cosmos chain, you need to have your own validator set. You need to make sure you have a secure validator set. And so like you can't just like deploy your own chain in seconds and have it be secure. But rollups fix that problem because rollups they inherit security from the layer. So like you only need one sequencer. Like if you're secure with just one sequencer, you're secure. Because you don't have to trust the sequencer. Even if they misbehave or if they try to censor people, you can get sensitive resistance from the layer. So it's way less overhead than all of our kind of like solutions like subnets or traditional Cosmos chains or Polkadot chains.
Mm-hmm. Gotcha. And unfortunately, I think we ran out of time. I wish we had like 2 more hours because I have so many more questions to ask you. But thank you so much, Mustafa, for joining us today. And for those of you who are interested in Celestia, go check them out. And so today we are off. Thank you, Mustafa.
Thank you.